Okay, now absorption spectrum. So what is absorption spectrum? Here also white light is used. When white light from any source, when white light from any source is first passed through a solution, and then passed through the prism, and then pass through the prism, then it is observed that some dark lines are obtained, in between the colors, and these dark lines are due to the fact that when the light is passed through the solution of a chemical substance, some radiation of certain wavelength are absorbed by the solution. When white light from any source is first passed through a solution and then passed through the prism, then it is observed that some dark lines are obtained in between the colors, and these dark lines are due to the fact that when light is passed through the solution of a chemical substance, some radiation of certain wavelength are absorbed by the solution. For example, suppose this is a source of light. These are the radiation of light. When the radiation of light, first time you have to pass through a solution. This is a solution of a chemical substance. Some specific chemical substances are used which can absorb the radiation. So this is a solution, and this is white light. After passing through the solution, the radiation you have to pass through the prism, and after passing through the prism you have to receive on the photographic plate. When you receive on the photographic plate, again you will get 7 band of colors from violet to red, like continuous, VIBGYOR. Again you will get 7 band of colors, but here in between the color you will get some dark line. This is your dark line. Similarly, this is your dark line. So like this way, some dark lines are obtained, and these dark lines are obtained due to using of this solution, because this solution can absorb some radiation of certain wavelength, and due to absorption of radiation you will get the dark lines in between the colors. And this type of spectrum obtained is called the absorption spectrum. So what is the difference between continuous and absorption spectrum? In both the spectrum you have to use white light. But the difference is, to get absorption spectrum, first time the light you have to pass through a solution. But to get the continuous spectrum, directly you can pass through the prism. And in continuous spectrum, there should not be any dark spaces in between the colors. Continuously one color, one by one color you will get. But in case of absorption spectrum, you will get some dark line in between the colors. So this is the difference between the emission spectrum and absorption spectrum. Now, as I have already told you, atom produce colored light, and that is why atom shows emission spectrum. And since it produce colored light, so you will get mainly the line spectrum. So now we will study about the spectrum of hydrogen. Emission spectrum of hydrogen. When we discovered in the structure of atom, initially we have done about the discovery of electron, discovery of proton, and in the discovery of electron proton you have got inside a discharge tube we have taken hydrogen gas at low pressure. And when you take hydrogen gas at low pressure and when you apply high voltage of electricity, then the hydrogen gas will produce a green color light when you get the cathode ray and anode ray. So that light produced by hydrogen gas, if that light is passed through a prism and then received on the photographic plate, then you can see the line spectrum of hydrogen, and which is called the emission spectrum of hydrogen. So hydrogen gas, when you take inside the discharge tube at low pressure and when you apply high voltage of electricity, then hydrogen gas will produce a green color light, already you have got. And if that green color light is passed through a prism, after that when you receive on the photographic plate, then you can see the emission spectrum of hydrogen. And it is found that in the emission spectrum of hydrogen, I mean in the line spectrum of hydrogen, hydrogen consists of a large number of lines which are grouped together, and they are classified into some series. So the spectrum of hydrogen, you will get this type of lines, and the lines are grouped together. This is a group of lines. In the hydrogen spectrum you can see this type of lines. This is a group of line. This is another group of line. So some group of lines you can see, and which are classified into different series. These are the group of lines. Similarly, this is another group of lines. This type of spectrum shown by your hydrogen atom when the light of hydrogen is passed through the prism. This is another series of lines. So like this way you will get number of lines which are grouped together and they are classified into some series. So like this way you will get 5 series of lines. The first series of lines, this is called Lyman series, Lyman. This is called Lyman series. Second series is called Balmer series. You should know about the series. Third series is called Paschen series. Next series is called Brackett series. And the last series is called P-Fan series. So when you observe the spectrum of hydrogen, it is found that hydrogen contains large number of lines, and these lines are classified into some groups, into some series. The first series is called Lyman series, second series is called Balmer series, third series is called Paschen series, next series is called Brackett, next series is called P-Fan series. Like this, the series lines are classified into 5 series. This Lyman series falls in the UV region. Then this Balmer series, it is in visible portion, and these 3 series are in infrared proportion depending on their wavelength. Thank you.